Hello friends, in this video we can learn how to find the solution of 1D wave equation by D'Alembert's method, right? So before we start, please do subscribe that channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID, Oja, OJHA, Lakhjit, LAKHYA, Lakhjit 123. This is my Insta ID. You can follow me on Insta. So now let's start. So here you see this is our one-dimensional wave equation. So let me give it equation number 1. And in order to solve this, let us consider two independent variables, u and y, right? So let us consider u. So let me write in black. U is equal to, suppose, x plus c into t, and v is equal to x minus c into t, where or you can write here, so that this y becomes functional function of both u and v. Now here you see we have from left hand side and right hand side, it is clear that y is a function of x and t both. So that's why if you consider u is equal to x plus ct and v is equal to x minus ct, so it is obvious that y must be a function of u and v, right? So hope you have understood this. Now you see what we can do here. We can write del y by del x. It can be written as del y by del u into del u by del x, right? Similarly, not similarly here, as I have said that y is a function of both u and v, so that's why this plus we can write del u by del v into del v by del x. That's how we can write, right? Hope you have understood this. Sorry, this should be y. This is supposed to be y. Okay, so we can write this way. Now here you see from this one, if you find del u by del x from here, what you're gonna get, this is gonna be equal to 1. Here see here this is not function of t, that's gonna be this is not function of x, that's gonna be 0, right? If you differentiate this with respect to x, so that's why we're gonna get 1 plus 0, so that is 1, right? So del u by del x is equal to 1, so we can put here 1, right? Similarly, if you differentiate this with respect to x, del v by del x, this is gonna be equal to 1 minus this part is constant, so that's gonna be again equal to 0, because this is not a function of x. If you differentiate with respect to x, that's going to be 0. So dv by dx is also equal to 1. So this is also equal to 1. So we can write here, that is del y by del x is equal to del y by del u plus del y by del v. That's what we have got. And this implies, this equation implies that del x is equal to del u plus del v. We can write this way, right? This implies this. Okay, now here you see we can write, therefore second order derivative of y with respect to x, what we can do, we can write this one as del x operates del y by del x, right? And we can replace this del x by this, right? and del y by del x by this. Okay, using these two results, what we're gonna get, we're gonna have here, so we have seen that del x is nothing but here del x is nothing but del u plus del v, and similarly del y by del x is nothing but here you can see this del y by del u plus del y by del v, right? Now first we're going to operate this by this operator, then we're going to operate it again by using this operator, and if we do so, then what we're going to have, so then we're going to have second order derivative of y with respect to x, which is equal which is this, it's going to be equal to, if you operate this one by this, then you're going to get second order derivative of y with respect to u, and then plus then this one by this, right? Then you're going to have second order derivative of y with respect to u and v, right? Then plus again this one with this one, then that's going to be again second order derivative of y del 2y by del u del v. So these two are same terms, so we can, instead of writing twice, we can write here 2. Okay, then plus now this one with this one, then what we're gonna have, we're gonna have second order derivative of y with respect to v. That's what we're gonna have. So hope you have understood this, right? So now let me clean these things, just wait. Okay, so this is what we have got. Now here you see, again let us find second order derivative of y with respect to time t. So in order to find that, so what we can do here, del y by del t, which can be written as del y by del u into del u by del t plus again del y by del v into del v by del t. That's what we can write. And again, if you differentiate this with respect to t, then you're gonna get c here, because this is gonna be 0 with respect to t if you differentiate, and if you differentiate this with respect to t, then you're gonna get c. So that's why del u by del t, that's gonna be equal to c. So that's why we're gonna put here c. Similarly, if you find del v by del t, then that's gonna be 0 minus c into 1, that's gonna be minus c. So that's why what we can do here, just give me a second. Okay, so we can replace this del v by del t by minus c, this one plus c and this one minus c. So if we do that, then what we're gonna have, just wait, give me a second, just wait. Okay, now that's gonna be equal to del y by del u, c will be taken common, minus del y by del v. Okay, because here we have got minus c, so now c is taken common, right? That's what we're gonna have. Okay, so similarly we can find second order derivative of y with respect to t, and this can be written as del t and del y by del t, right? And we can replace this del t here. You see this equation implies what does it imply? It implies that del t, that's going to be equal to del u plus del v into c, right? That's what it does. What we can do, we can replace this one by this result, and we can replace this by this. Okay, hope you have understood this, because del y by del t is equal to this one, right? So if we do that, then if we put all these things, then what we can do, so instead of del t, let's write this del u plus del del u plus del v into c, right? Then we're gonna get del y by del u minus, sorry, it's supposed to be minus, okay, this is also minus del y by del v, and here also c, so this c again we can write c square, so that's why let me cut this c, so instead of that I'm writing here c square. Okay, so hope you have understood this. So now what we are going to do now in this case, so we're going to use this results in this one and this one. Okay, so let me write. Now you see, let me take this as equation number suppose 3, this is suppose equation number 2, and this is suppose equation number 3. Now let us use these two equations in equation number 1. So we're going to replace this by this result, right? So if you simplify this result, what you're gonna have, first let me simplify this equation number 3, just wait. So let's give it equation number 2. So let me copy equation number 1. Okay, take a new slide. This is equation number 1 and this is equation number 2. Let me go to the new slide, just wait. Let me copy the equation number 2. Okay, so this is the second equation, and the last one, this is the last equation we get. So from here we can simplify, this is the last equation we have got. So now let's operate this one by this. So what we're gonna have, del 2y by del t2, that's gonna be equal to del 2y by del u2, right? Then operate this one by this, then you're gonna have minus del 2y by del u del v, right? Del u del v, then plus, if you operate this two, if you operate this term by this second term, then sorry, not this one, just wait. If you operate this with by this, then you're gonna have again del 2y by del v and del u, or del u and del v, same thing. So these two terms are exactly same, so instead of writing this, we can write here 2. Okay, we can write this way. And now let's operate this last term by this. Okay, then what we're gonna get, let me clean this. Okay, just give me a second. Okay, then you're gonna get plus second order derivative of y with respect to v. That's what we're gonna have. So now we're gonna use this value here, and we're gonna use this value, you can see here, right? So using 2 and 3, this is suppose equation number 3. So using 2 and 3 in 1, right? In 1, what we're gonna have, so now you see this is equation number 1, so this is equation number 1. So now just wait, just wait. Okay, now let me remove this and let us put this value here. Then what we're gonna have, so instead of this we will get this part. Just give me a second. Okay, let me bring it here. Okay, let me copy this. Okay, this is what we're gonna have, and now let me remove this, and instead of this, what we're gonna have this value here. You can see we can put this. So this is what we have got after simplification. Okay, so now let me cut this equation number 2, and this equation was already written in previous slide, so let me cut this as well. and then after this step we had got this equation number 3. So let me keep the equation number 3 here. Okay, so now just wait, let me rearrange these things. Okay, here what we have got. Okay, one more thing, I think I have missed something in equation number 3. I have missed this c square. So here I should write c square here. Okay, so I missed this c square. Okay, so that's why if that is the case, then we must write c square here as well. Okay, c square. Okay, now you see this 2 c square cancels, right? Now let's open the bracket, then simplify. So after simplification, what you're gonna have, just give me a second. Okay, so this result we're gonna have after this is 2. Okay, this is supposed to, this is 2. Okay, now here what we have got, this one cancel, this one cancel. So after cancellation, what we're gonna have, if you transfer this one to other side, and one more thing, so -2 and +2, that's gonna be cancelled, right? Sorry, if you divide both sides by 2, here you see, just wait. So this is what we have got. Now 2 cancels. Okay, now what we're gonna have, if you transfer this one to other side, then del u del v plus, okay, del 2y by del u del v, that is equal to 0, and adding these two, what we're gonna get, we're gonna get here 2, and dividing both sides by 2, so it's gonna be equal to 0, right? Hope you have understood this. This is what we have got. Sorry, just let me write it clearly. Okay, so now let me copy this last step and let me take a new slide. Now let me take a new slide, and here is the last step we have got. Now what we are going to do, we're going to integrate it with respect to b. Okay, so now you see, if you if there is 0, we can consider this way. Sorry, we can take this 0 as derivative of f of u with respect to b. Okay, because if you take if you differentiate it partially with respect to b, that's going to be 0 because it is a function of u. So in that case, if you integrate it with respect to b, then you're gonna get integrating with respect to b, then you're gonna have del y by del u is equal to f of u, right? We can write, so f of u is constant with respect to b, right? With respect to b. So hope you have understood this. Now if you integrate it again with respect to u, now if you integrate it again, right, with respect to u, then what you gonna have? Now you see, again integrating with respect to u, in that case we're gonna have y is equal to integration of f of u du, right? Integration of f of u du plus we're gonna have a function of v, that means which is a constant with respect to u, right? When we had integrated it with respect to v, we have got here f of u, which is a constant with respect to v, right? So similarly, when we integrate it again with respect to u, then so integrating left hand side we have got y, and integrating right hand side, integration of f of u with respect to u, then we must get a constant with respect to v. That means this is a function of v, it is a constant with respect to u. Okay, psi of v is constant with respect to u, right? So hope you have understood this thing is clear to you. I hope so. So now what we can do now, so now let me take this one as phi of u, which is a function of u, right? So in that case what we can write, y is equal to phi of u plus psi of v. Okay, let's say phi of u is equal to, phi of u is nothing but, integration of f of u du, right? Integration of f of u du. Okay, so I have considered that way. So now you see u is nothing but x plus ct and v is nothing but x minus ct, as we have considered earlier, right? Here you see in the previous first slide, here this is u, this is v. So if we put those values here, then this y gonna be equal to phi, instead of u we're gonna write x plus c into t, then psi of, instead of v we're gonna write x minus c into t. That's what we're gonna have. So let me take this as equation number 4. Suppose this is equation number 4. Now this equation number 4 is the D'Alembert solution of wave equation. This is D'Alembert's solution of wave equation. So now if we wish to obtain these two, phi and psi, let us differentiate this equation with respect to t. Differentiating equation number 2 with respect to time t, and here let me write as t. Okay, so in that case we're gonna have del y by del t, right? Del y by del t, and derivative of phi we're gonna write phi dash, and this is function of function. If you differentiate this x plus ct with respect to t, then you're gonna get c here. So let me write here c. Similarly you're gonna get c phi dash x minus ct. So here we have minus c, so that's why this is supposed to be minus. Okay, so this is what we're gonna have, right? So now let me take this as equation number 5. Okay, so this is not 2, this is supposed to be 4. We have here differentiating equation number 4 with respect to t. So we have got this equation number 5. Now you see when t is equal to 0, we know this y, it is a function of y is a function of x and t. When t is equal to 0, then y x comma t, that's going to be equal to, here we're going to put t is equal to 0, then this equation turns out to be, you know, so then del just give me a second, just wait. You know, when t is equal to 0, you see this rate of change of y with respect to t, that must be equal to 0, right? So now at t is equal to 0, this part, you see, if you put t is equal to 0 here, then del y by del t, it becomes c phi dash of x plus, sorry, not plus, minus, that's supposed to be minus, okay, then c psi dash, and this becomes 0 on putting t is equal to 0, so that's why psi dash of x, that is equal to 0, right? So hope you have understood this. So this implies c psi dash of x is equal to c psi dash of x, right? So here c cancels. So now let me go to a new slide. Let me take a new slide. So let me write the last step. What we have got after cancelling c from both sides, we have got c dash of x, and on the other side we got psi dash of x. That's what we have got, right? Here you can see. So now if we integrate both sides, if we integrate, so this is psi dash, so integrating both sides, we get, what we're gonna have, derivative will be removed, so here we're gonna get psi x, and we need an integrating constant. Let it be, suppose b, okay, let us suppose this is b. Now this is suppose equation number 6. So last equation was equation number 5, so I have taken here 6. Now what we can do, again putting again, you see, when you put t is equal to 0, just let me just, okay, now here you see from equation number 4, when you put t is equal to 0 here, then y will be only function of x, right? If you see that equation, so let me copy this equation number 4. Here you see, okay, again putting t is equal to 0 in 4, we're gonna get y is equal to, so this is gonna be equal to 0, this is gonna be also equal to 0, so that's why we're gonna get phi of x plus then psi of x. So we can say this is a function of x, so let me take it is f of x, okay, let us say this is. So now what we can do here, you see, just let us put this value of phi here using 6. What we're gonna get, f of x is equal to, instead of psi of x we're gonna get instead of phi of x we're gonna get psi of x plus b, then we're gonna get psi of x plus b, then plus psi of x. So this implies f of x is equal to 2 psi of x plus b. That's what we're gonna have, and this implies psi of x. If you simplify this, then what you're gonna have, f of x minus b divided by 2, right? Now let's put this value. So here I forgot to write, using 6, okay, using 6, okay, because I have put this value in this one here from equation number 6, right? Now let it be equation number 7. Now using 7 in 6, using 7 in 6, so if we use that in 6, then what we're gonna have, phi of x, instead of psi we're gonna put f of x minus b by 2, then we have plus b, and if you take LCM and simplify it, then again it's gonna be equal to f of x. Now it's gonna be plus b by 2. So this is what we have got. So now we have got phi of x and psi of x, right? So now what to do? Here you see, let me go back to the previous slide. Here you see we have got the solution. This is the solution, right? D'Alembert solution. So here in this solution, here we have psi of x plus ct, right? And here we have psi of x minus ct, phi of x plus ct and psi of x minus ct. Let me copy this equation number 4. Okay, and let me write here. This was the solution, D'Alembert solution. So we have got psi of x here, and we have got phi of x here. So therefore psi of x plus ct. So here we have x minus ct. So let's find x minus ct. Psi of x minus ct. Now psi of x is this one. So if you put here x minus ct, then this x should be also replaced by x minus ct, right? And then this is going to be equal to f of x minus ct minus b by 2, and similarly phi of x plus ct, as we have x plus ct here, you can see in equation number 4. So phi of x plus ct, now replace this x by x plus ct and replace this x by x plus ct. So then our result going to be equal to f of x plus ct minus b, sorry, not minus b, plus b. Here we have plus b divided by 2. That's what we have got. Now let us use these two here. Okay, so then therefore equation number 4 implies y is equal to f of x plus ct plus b by 2, then plus f of x minus ct by 2, right? And here it's supposed to be minus b. Okay, so hope you have understood this. And if you take the half common, then what you can write, we can write this way, like this, just wait. So here we have taken half common, then here you can see it is clearly clearly you can see this plus b minus b will be cancelled. So then our result will be this is going to be our final result. So here it is plus, so let me use here curly bracket. Okay, so this is the result. Okay, so this is the required solution. So hope you have understood this. Thank you for watching. See you in the next video. Bye bye.